online tutors.
So I'm going to give an introduction to chemistry, and what you can see here is something called the periodic table, and it's a table that shows all of the different elements in the universe that have been discovered. So for example, here we have the helium element. Here we have the hydrogen element. Here we have lithium. And you can see that each block represents a specific element. Each one of these elements in a specific ratio or combination is what creates the universe. Just how you have a cake. The ingredients to create a cake require flour, eggs, and water. These are the ingredients. But the ratio of these ingredients will give you a specific cake. You can change the ratio of flour to eggs to water to create a specific type of egg. And each one of these elements in the periodic table are the ingredients to create anything in the universe, which includes the mountains, the human species, an insect, even the galaxies, the sun, the stars. Every single thing in the universe is built up of an element from this periodic table in a specific combination. So let's understand what this periodic table is. We have here something called the key, and this is similar to a video game. In a video game, you have something called the map, and the map tells you how to get to places, how to navigate the area. And on the map, you usually have symbols. On the map, you usually have symbols. So we have a star symbol here and the flag symbol here. And somewhere on the map, you have something called the legend or the key. And this is what tells you what each symbol means. So for example, the star means quest, and the flag means a race. So in the periodic table, the key, which it says here, the key tells you how to navigate this periodic table and tells you what it means. So each one of these elements are atoms. The smallest atom is the first one here, the hydrogen atom. The hydrogen atom has a number 1 on the top with the symbol H. It says hydrogen, and also a number 1 on the bottom. And what allows us to understand what this means, what do these symbols mean, is the key here. The number on the top is the atomic number. In this case, it's 1. In the key, it then says symbol, and this is the symbol that represents this element, which is H for hydrogen. Then it says name, and the name is called hydrogen. Then it says the relative atomic mass. So that's the mass of this atom, which is hydrogen. Each one of these atoms is made up of 3 things. It's made up of a positive energy field, a negative energy field, and a neutral energy field. So the positive energy field is more commonly known as the proton. It has a positive energy. The negative energy field is known as the electron in English, and the neutral energy field is known as the neutron. A way to memorize the energy field with the name would be that proton begins with P, which is positive. Neutron has the alphabet Neutr, and so does neutral. And obviously the third one is the last one left out, which is electron, and the only option left is a negative energy field. So you only actually need to memorize 2 to have memorized 3, because if P is for proton, which is positive, the only 2 options left over are negative and neutral energy fields. And you know, neutral is neutron because they both begin with the same alphabets. Therefore, the only options left over are electrons or negative. So the proton has a positive energy field. The electron has a negative energy field, and the neutron has 0 energy field. It has a neutral energy field. These three things, the proton, neutron, and electron, the ratio of them, the combination of them, is what gives you all of these different elements. So let's go back to the hydrogen atom. The number on the top, which is the atomic number, tells you the number of protons and electrons for that atom. So for the hydrogen, the atomic number is 1. Therefore, it has 1 proton and 1 electron. To find the number of neutrons for the hydrogen atom, we have to take a look at the number on the bottom, which is the relative atomic mass. And let's kind of understand what this word means. Relative atomic mass. So atomic mass, if we break down the word, it's built up of the word atomic, which basically means the atom we're looking at, which is the hydrogen atom, and the mass, right? The weight on Earth of that specific atom. So the atomic mass is basically the mass of the atom, and the atom we're looking at is the hydrogen atom. So the mass of each different atom is different. The mass of helium here is 4. But there's an extra word. It says the relative atomic mass. Relative is kind of like the word comparison. You compare it to something. And in reality, the mass of the proton, the neutron, and the electron cannot be measured. They're too small. These are things that the human eye cannot see. The relative atomic mass is what is observed. What does that mean? Well, for example, imagine you have a cup of water, and this cup of water has a mass of 10 grams, and you go to the ocean. What you do is you pour the cup of water into the ocean. Now, does the mass of the ocean change in any way? No. Adding a cup of water, a glass of water, pouring a glass of water into the ocean at the beach is barely going to make a change to the mass of the ocean. So we can say that the mass of the glass of water relative, so the key word now, relative to the mass of the ocean is 0. In reality, obviously the cup of water does not weigh 0. The glass of water does not weigh 0. It has a mass of 10 grams. But compared to the ocean, relative to the ocean, it weighs 0. So if we take a look at the proton, neutron, and electron, their masses are relative to each other, in comparison to each other. And the mass of the proton is basically 1, and the mass of the neutron is also 1. Relative to each other, the mass of the proton and the neutron weigh the same. Now, we don't know how much that weighs. We don't know how much that mass is. We don't know how much they actually weigh. What is their true mass? But what we do know is that relative to each other, they have the same mass. Now, relative to the proton and the neutron, the electron has a mass of 0. Relative to the other two, it basically weighs nothing. The same way the glass of water had a mass of 0 in comparison to the ocean, the mass of the electron is basically 0 compared to the proton and the neutron. The relative atomic mass of the hydrogen atom is 1. And we're told this because it says this on the periodic table. That means the whole mass of the hydrogen atom should equal to 1. Well, what is the hydrogen atom made out of? Well, it's made out of protons. And we know it's made out of 1 proton, because we got that from the atomic number. We also know it's made out of 1 electron, because we also got that from the atomic number. We also know that there are neutrons present, but we don't know how many neutrons there are present. So let's call that x in algebra. So we know the total number of protons plus electrons plus neutrons should equal to 1, because we know that the number on the bottom, which is the relative atomic mass of the hydrogen atom, has a relative mass of 1. Therefore, the total mass of the protons plus electrons plus neutrons should equal to 1. And what we're trying to do now is find out how many neutrons are present in the hydrogen atom. So we know that the mass of the electron is basically 0, so we can cancel the electron out. It doesn't matter if there's 100 electrons present. Relative to the other two, the mass is 0. So the equation becomes more simple. We have 1 proton plus x, which is the unknown number of neutrons, is equal to the relative atomic mass of 1. And we rearrange using algebra. X is equal to 1 minus 1. Therefore, x is equal to 0, and x was the number of neutrons. So the hydrogen atom has no neutrons. No neutrons. So the number of neutrons in the hydrogen atom is 0. So now we've figured out the combination of protons, electrons, and neutrons in the hydrogen atom. And we figured this out by looking at the periodic table. If this algebra did not make sense, then all you simply need to do is take the relative atomic mass, which is from the periodic table, and from it you need to subtract the atomic number to give you the number of neutrons. If you prefer remembering it this way, then you can use this. Right? You take the relative atomic mass, which in this case is the number on the bottom, and you subtract from it the number on the top. And it will give you 0, which means that the hydrogen atom has 0 neutrons. Why have we done this? Well, we're trying to draw what the hydrogen atom kind of looks like. And to draw what the hydrogen atom looks like, the model of the hydrogen atom, we need to be able to know what it's made up of. So now we know it's made up of 1 proton, 1 electron, and 0 neutrons. But they have specific laws that they have to follow in terms of how the picture ends up being drawn. So what they don't look like, if we say the proton is this circular dot, and the electron is this blue dot, and the neutron is this cyan dot, what it does not look like is a random proton here and a random electron flying around inside of a box. There's a specific way you have to draw the hydrogen model for exams, and you may know that as the dot cross diagram. So just like in biology, you have in the center of the cell the nucleus. In the dot cross diagram, the atomic model. And in this example, we're looking at hydrogen. So the atomic model for hydrogen, we have a nucleus in the center. And this nucleus in the center is where the proton and the neutron is located. So in the nucleus, we have the 1 proton. Now the hydrogen atom does not have any neutrons, so I'm not going to draw the neutrons. So this is the nucleus. It is the center of the atom. Orbiting the atom, just how the moon orbits the Earth and the planets orbit around the sun, you can kind of think of the nucleus being the sun and the planets being the electrons. The electrons rotate and orbit around the nucleus at a fixed energy level. Which drawn here is the first energy level. Or you may have read this as the first shell or the first ring. Now this picture is in 2D, it's in 2 dimensions. And the reality we live in is 3 dimensions. So what I've drawn here as circles in 2D will actually be spheres in 3D. So this actually happens in 3 dimensions. So what we have here is the atomic model for the hydrogen atom. So to summarize what we've covered in this video, we should now be able to take a look at an element in the periodic table, and the element we took a look at was hydrogen. And we saw that it had a 1 on the top and a 1 on the bottom. Now in this periodic table, the number 1 on the bottom is actually the relative atomic mass. Now, different periodic tables may invert them, right? So in this periodic table, the relative atomic mass is on the bottom and the atomic number is on the top. But in some periodic tables, they may switch these two numbers. So you have to pay attention to the periodic table you're looking at. You have to refer to the key. So what we are able to do is take a look at the number on the top and realize this is the atomic number. And this tells us the number of protons and electrons for this specific atom, which is 1 proton and 1 electron. We can take the relative atomic mass, which would give us 0, and subtract from it we have the atomic number, neutrons. And we're able to draw the atomic model. The atomic model. And in the center of the model is where the protons go. So if the proton is this red dot, that's where they go, in the center. The protons go in the center. And remember, they have a positive 1 charge. And orbiting the center is the electrons. If we say the electron is this blue dot, here is the electron. And the electron has a negative 1 charge. So the overall charge of this hydrogen atom is negative 1 from the 1 electron and positive 1 from the proton, which gives an overall charge of 0.